Okay, so this is our third 4 point. This says 4.4. Wow, it is 4.4. Okay, this is really C, I guess. So going back to what we first learned in our first packet, A is the same, has not changed, it's still our amplitude. It still tells us the same thing from the center, from that anchor point to the maxes, and from the anchor point to the mins. That's going to be our distance A. This has not changed. It is still omega. It is not W. Please don't call it W. It's one of my pet peeves. Omega is equal to 2 pi over T, where T is the period, and T is equal to 2 pi over omega. Okay. What we're adding in that's new today is just shifts. This plus or minus H here is going to give us our horizontal shift. You did. I wasn't here for it. I guess what I'm saying is what I'm adding in today that's new is the horizontal shift. And it's just like when we were doing transformations. If you had an X minus 3, that would actually move it to the right by 3. If you had an X plus 1, that would actually move it to the left by 1. So it's inside, so it's kind of backwards. And then K is going to give us our vertical shift. And since this is outside of the function, it's as you would expect. If you had a +5, that would move it up. If you had a -2, that would move it down. So I'd like to just start with just dealing with horizontal. And I know that you guys have already dealt with some verticals and horizontal, but let's focus on the horizontals for right now. So we're going to graph this function. We'll start it off the same way that we did before. We'll notice that it's a positive cosine and that our amplitude is 2. That's fine. Omega is pi over 2. We're going to need a period. So using omega, we should be able to find a period. The period is 2 pi divided by pi over 2. So that would be the same as taking 2 pi times the reciprocal of pi over 2. Pi's are going to cancel. That's going to give us 4. And a lot of you have probably already latched on to the little shortcut, right? You're just looking at the denominator and doubling it when it's pi over a number. That's fine. You don't have to show this work. I'm okay with it. Tell me about this shift. Is this a shift 1 to the left or 1 to the right? That's to the right by 1. So the only thing that's different for us right now is that our anchor point's no longer going to be at the origin. We're going to shift our anchor point 1 unit to the right. So we'll be anchoring at this point here. And this is where we're going to start drawing our box. So our amplitude is going to tell us how far up and how far down. Amplitude's 2, so we'll go up and down by 2. T or period tells us how wide to make the box. So we'll make it 4 units wide. And as usual, we will be dividing our box up into 4 segments, or 8. Yes. That gives us a framework to build our positive cosine. We just need to remember what our positive cosines, and you guys are getting pretty good at remembering what a positive, negative cosine, positive, negative sine are looking like. Awesome. This is working out pretty well. And I imagine at this point, some of you have started to come up with some little tricks to make the tedious part go a little bit faster. I always do my x-intercepts first, but you go ahead and do whatever you need to do to fill out the rest of our graph. When I do it, I find it quickest to do the x-intercepts first. I'm noticing they're 2 units apart because that's half a period. So I'm going to do all my x-intercepts first. And then I'll come back and do my maxes and mins in between those. But whatever techniques you've developed at this point to speed this process up, it is tedious. but you are going to get pretty quick at it over time. As you're finishing that up, I just want to reiterate that it's super important when you're practicing this that you are not reaching for your calculator until you have finished making your points on your graph. If you are graphing the equation first and then trying to draw the graph from your graphing calculator, you're doing it wrong. Okay, there will be a portion of your test where I'll be asking you to graph these things and you will not have access to a calculator during that portion. You need to be able to do these by hand without your calculator. Make sure you're practicing it that way. Please do graph it in your calculator, but only after you've done it by hand to check and make sure you're doing it correctly. Okay. Let's just do another one really quickly. So again, do this. It seems like most of you are getting pretty confident. Go ahead and do this next one as quickly as you can on your own. I'm going to work through it kind of quietly up here. Right. Keep going. Keep graphing, and then check against mine. And as you're finishing up, just keep going. You can multitask here. I was having a conversation with several of you last Wednesday about how, as math teachers and teachers in general, sometimes we don't expose you to the whole truth right away. We kind of give it to you in bits and chunks just so you don't have to deal with the complexities of everything. The classic example being in Algebra 1, you were told that you cannot take the square root of a negative number. And then Algebra 2, we revealed, well, you actually can. You just have to deal with these things called imaginary numbers, right? So when I first introduced this to you last week, I taught you that there was a difference between a sine and a cosine, and that a sine looked like this and a cosine looked like this. Last Wednesday, if I had given you this graph right here and asked you if it was a sine or a cosine, what would you have told me last Wednesday? You said you would have said this was a cosine, right? Positive or negative cosine. Looks like a negative cosine, right? It's not going through the origin. It's starting at a minimum on the y-axis. But we just graphed a sine, and it gave us this graph. So it's not a cosine, it's a sine. Well, it turns out there's really no difference between a sine and a cosine. You can take any cosine equation and make it look like a sine graph and vice versa. It's just a matter of shifting it by the right amount, and you can turn anything into anything else in terms of sines and cosine. So I apologize, I wasn't trying to lie to you or mislead you or anything, but just to kind of keep things a little bit simple for our first exposure to it. Okay, We did not go over anything like example 3 and 4. What looks different about these ones to you? Are they in that same format that you had up at the top of your page? A little different though, aren't they? Notice in the format up at the top of your page, omega is the coefficient on everything else inside of the function, not just the x, but on everything. Everything else is grouped, also being multiplied by omega, and that is not the case here. So this is not in the correct format. I cannot look at this equation and tell you just yet what my left or right shift is. I can tell you it's going to be going to the left because it's plus, but I can't tell you how far it is. So I need to do a little bit of work to turn this into the format that I want to see, which is going to have a x in parentheses with omega sitting outside of those parentheses. So essentially, what am I doing with that pi over 4? We're dividing it. Another way I could think about that would be, it's that F word. We're factoring it out. And when we factor something out, it is division. So we're factoring this pi over 4 out in front of this set of parentheses. And when we do that, then we just need to divide. So I need to take this 3 pi over 2 here. And in order to factor out the pi over 4, I just need to divide it by pi over 4. And this seems like it's going to be a huge pain, but we got this, right? We know how to divide fractions. We just flip and multiply. Just flip and multiply. I's will cancel. We end up with 12 over 2, which is 6. So a little bit of extra work to figure out that this one is going to be shifted to the left by 6. I'm going to use our shortcut to find t. Are you guys comfortable with me doing that? Pi over 4, double that 4, t is going to be 8. We'll talk about why that works in just a minute. All right, let's go ahead and graph this. And by the way, I'm going to change example 4 in just a second, so maybe don't start on that just yet in case you're getting a little ahead of me. Okay, so anchor points usually at the origin. We're going to shift to the left by 6 and anchor it right there. The amplitude of 3 tells me how far up and down I'll go from there. And our period's going to be 8 this time. Dealing with a positive sign. And then we just need to make our copies. Before we move on to the next one, I'm going to pause here for a little while. I know most of you are still finishing up making your graphs, but I want to give you a second to just look over these 3 examples we've done and ask some questions. You guys feeling pretty good about these? I'm curious, on a scale from 1 to 5, how fun is this? Like math fun, right? You know, not like math fun, yeah. 7 to 8, wow. 3 to 4, oh, I was adding them. I thought you said 7 out of 5. That's awesome. On a scale from 1 to 5, how confident are you feeling about this? Okay. Seeing 3s and 4s and 5s. We're in the learning phase. That's good. Okay. I want you to make a small change to example 4. Could you change that 3 pi to a 4 pi, please? And let's go ahead and work this out. Just like the last one, we're going to need to do a little bit of work to get this into the correct format so that we can start looking at our horizontal shifts. So right now, everything inside is kind of all together. We need to separate out this pi over 2. We're going to factor it out of everything inside of there. So it's just going to leave the x there, and then we need to divide 4 pi by a pi over 2 to figure out what goes over here. So we'll do a little work off to the side. 4 pi divided by pi over 2. That's the same as do your keep, flip, change, or your just flip and multiply, however you think of that. To get 8 this time. Oop, minus 8, not plus 8. So I can see that we're shifting to the right by 8. And I'm going to use our little shortcut again. T is 4. And this came up a little bit in the work that you guys did on Friday. I just want to see how you dealt with this. So we take our anchor point, we shift it to the right by 8. That moves it over to here. But I'm going to have some trouble when I go to start drawing that box. Do you see the trouble I'm going to have? I know I'm going to go up and down by 3 because that's our amplitude. But I want this box to be 4 units wide, and I don't have enough space to do that on my graph. Anybody want to offer a solution to this? What do you think, Gabby? Mm-hmm. Oh, I like that wording. It resets every box. These things repeat themselves over and over again, right? There is a period that starts here and goes 4 units to the right, but isn't there another period that comes right before this? There's periods way before it even. Right. So I could start here and go to the right, or I could start here and go to the left, because there is another period that's going to come right before this. It's also going to be 4 units wide. Another idea? Okay. So you would kind of draw it off to the side here. Yeah, and that works too. Oh, okay. You would add the periods, the points you can see here, and then kind of follow the pattern over. Yeah, yeah, okay, yeah. So I just conceptually, are we okay with why I drew my box going this way instead of this way? There is another exact replica of this box right here, correct? So it doesn't really matter which of these boxes I draw. So I'm going to go ahead and do this one. And I want to talk really briefly one more thing about this problem before we flip over in the back. This is a negative cosine. Wait a second. And keep in mind, I'm not modeling the step that I do expect you to do with these when you're doing them on your homework, which is grab your graphing calculator, graph the equation, and make sure that you're seeing the same graph, right? So just really quickly, if I get your attention for a second, there's something pretty important I want you to see here. We graphed a negative cosine that started at +8, right? Because of our shift to the right of 8. But in graphing it, we actually used the period that started here at, where is that, at 4. So we actually graphed a version where it was x minus, I don't know why I just wrote 6, but we actually graphed a version where it was actually x minus 4. And if you were to type this same equation in, but put a -4 instead of that -8, you would see this exact same graph. There's another way we could have graphed this also. What if there's another negative cosine that starts right here, right? So we could have done a +0. Now, what are you noticing about all these numbers here? How far apart are they? 4, which is the length of the period, and that's no coincidence, right? So there would be another one at +4 and at +8. So all of these equations, if I'm not going to copy this down again, but if I replace this -8 with all of these different variations, we're going to get the exact same graph. So it turns out, and hopefully you saw this on the work on Friday, is if I give you a graph and ask you for equation, there's not just one equation you can give me. There's actually an infinite number of equations you can give me. Please be kind to me when you take your test, okay? Give me something that is reasonable. Don't make me do a bunch of difficult math to figure out whether your answer is right or not. Right? Last year I had somebody do this and they were like, they wrote like x minus, 448 or something in there, which is right because 448 is a multiple of 4, right? So, but and I guess if you, I don't know, if you want to do that, that's fine. Write me a simple note too. Any question? Scientific notation, please don't. That wouldn't be simplified though. If you're saying like if I change this 448 into something where I actually had to do some math, then you're asking me to simplify, which I'd say your answer was correct, but not simplified fully. Okay. So that kind of piggybacks onto this. There are multiple equations that I could write for this graph right here. I'm asking you to write a negative sign graph. Where do you see a negative sign period starting on this graph? Where are you seeing that? -7, I agree. It looks like we've got a negative sign starting here and ending at 1. Did anybody see the negative sign that started at 1 and ended at 9 initially? There is one there too. And there would be many more that we can't see on the graph. We can see the end of one here and the start of one here. It doesn't matter which one we pick though, the period's going to be the same for each of them, right? What would that period be? From -7 to +1 is 8. So if we know the period is 8, then we should be able to find omega. Omega is 2 pi over the period. 2 pi over 8 is pi over 4. And again, it doesn't matter which of those we pick. How big is our amplitude going to be here? Looks like we're going up and down by 3. So we know our amplitude is going to be 3. And as far as our shift, we just need to shift from the origin to one of these starting points. And we've got options. We could have taken and moved from the origin to the left by 7. That would be a +7 in here. Or I could have moved to the right by 1. So instead of that +7, I could have written a -1 there. If I wanted to get really fancy, there is one starting here at 9. So I could do -9 because that's 9 units to the right. What's the next one after -9? -17, because they're one period apart, right? 1 to 9 is 8. Another 8 on top of 9 would give us 17. So there's going to be some more. Now, could we have written this as a cosine instead? Certainly could have. Could we have written it as a positive sign instead? Certainly could have. And that was kind of the whole point of example 6, but I think I'm going to skip over that right now if you guys are okay with that. I can always come back to number 6 later on if you'd like, but the idea was how many different equations can you write? And we know the answer to this now. It's an infinite number. Now, if I'm talking about just equations that we can see in here, of course, we can see, I don't know, the first one that jumps out to me is this positive cosine right here, but there's also a positive sign right here. We got a negative sign over here. We've got a negative cosine happening here. We've got lots of options. The amplitude, the period are always going to be the same. The only thing that's going to change is whether it's a positive or negative, whether it's a sine or a cosine, and then the shift that it takes to get to that left-hand edge of that period. You guys all right with the idea now that there is really no such thing as this positive or negative sine or cosine? They're all sort of the same thing, just shifted versions of each other. Awesome. Let's do one with a vertical shift. Let's go ahead and do example 8 because that gives us an opportunity to practice that whole getting it into the right format thing. So I'm skipping 7 for right now. Example 8 is not in the right format, so I'm going to go ahead and do my little small bit of work to do that. So I came up with a +2 on the inside of my parentheses. Can you guys verify? Which would be a shift to the left by 2. And the period would be 8. Okay, let me give you a really big hint for when you're doing your vertical shifting on this. I'm going to zoom this out a little bit. This is something that I stole from a student. But since I saw this, I picked it up and I use it anytime I have a vertical shift. So you see how it's got that -4? The very first thing I'm going to do before I do anything else is I'm going to draw a horizontal line at -4. This is where my y-axis kind of shifts to. That's going to be the center line for my function. Okay, so we've essentially just shifted the entire y-axis down by 4 because of that -4 at the end. And then from there, I'm going to use my amplitude of 6. So I'm going to go up by 6. I'm going to draw another line up here. I usually do them as dashed lines, but it doesn't really matter, to give me where my maxes are going to be. And then we'll also be going down by 6 from that center line. And this just gives me a nice framework that I can use to make sure that all of my points end up on one of those 3 lines, right? My maxes, my mins, and my what we used to call x-intercepts. Those center points are all going to end up on one of those 3 lines. All right, and then from here, it's basically, I'm thinking of this as my new origin. I need to shift that to the left by 2. So left by 2 gets me to this point right here. That becomes my new anchor point. And my box is going to go right up to the max, down to the min. And we said it was going to be 8 units wide. Yeah. Did I do it wrong? I did. Yeah, thank you for the correction. I was going too fast there. I went up 7. Glad you caught that. Thank you, thank you. So that should be here. Good eye. All right. Were any of you kind of already doing that on Friday, drawing those horizontal lines in? I find it super helpful. I wasn't originally, and I was getting points in the wrong place. And then I saw a student do that. I was like, that's really smart. Let's start doing that. I'm gonna chop this guy up and get our cosine on there. Negative cosine. So I think those horizontal lines help me a lot. Not just when I'm drawing the graphs, but also when I'm going the other direction. If I've got a graph and I'm trying to write an equation, which is what we're about to do next, first thing I'm going to do is draw those 3 horizontal lines in, except I'll start with the max and the min, and then use those to help me find that center line. You guys feeling okay about that one? And this is what you practiced on Friday. And again, it seemed like from what the sub said that you guys were feeling pretty successful with that. All right, so let's get into this next one. And again, I find it really helpful to draw these lines in. I'd say for this, it's almost more helpful than for the other type of problem. Those horizontal lines at the max and min are going to help me find the center line, which should be exactly halfway in between them. Do you guys know how to mathematically find a number that's halfway between 2 other numbers? This is a process that we teach students at a pretty young age. We use it a lot for like grades and that kind of thing. Yeah. Yeah, that's one way to do it. There's a simpler way. I think it's simpler. Starts with an A. Average. You average them. If you average 2 numbers, you will find the number that's exactly halfway between them. So this horizontal line's at -2 and this one's at +6. So average those. What's -2 plus 6? 4 divided by 2. 2. My center line is going to be at 2. Now it might not make as big of a difference for a problem like this, but when we get down to number 13 down below, it's going to be kind of helpful to us. Okay, so just remember to find that center line, you can just take the average of your max and your min. And you know how to take the average of 2 numbers, add them up and divide by 2. All right, so this asks us to write 4 different equations. I'm satisfied with just one here. What's jumping out at you? Positive, negative, sine, cosine. Someone help me out. Positive cosine. Both people seeing positive cosine. 2 people seeing positive cosine. And are you looking at the positive cosine that starts here at -9 or the one that starts at -1? At -1? All right, this looks good to me too. I like that positive cosine. I'm going to go ahead and draw a box around it. Width of that box is going to tell me the period. Looks like 8. So then we can find omega, which is 2 pi over the period. got our amplitude of 4, and we just need a shift. If we think of this as our anchor point, that has been shifted to the left by 1 and up by 2. So that's everything we need to write our equation. Got our amplitude, got our omega. Left by 1 is going to be +1, right? And our up 2 is going to be a +2 on the outside. And the last step that I'm not showing here is to do what? With our graphing calculators. Graph that equation in your graphing calculator, make sure that it looks like this. All right, you guys ready for the most fun thing of all? This is the one that my students just love every year. I'm being a little sarcastic here. My students love to complain about these. I'll be honest with you about that. So here's the deal. Hard truths, tough love here. Your graph's not always, your period's not always going to be a nice whole number. Okay. Your graph's not always going to be shifted by some nice number. A lot of times your period is going to be in terms of pi, and a lot of times your shift is going to be in terms of pi as well, which means we're going to need a graph that is marked off in terms of pi instead of whole numbers. And it's not a big deal. It's the same thing as before, but for some reason people start seeing pi's and radians and they're like, oh, I can't do this. This is so much harder now. Okay, so try and divorce yourself from that idea that radians are harder and just follow what we've been doing. So this is all kind of in the right format here. Now, are we going to be able to use our shortcut to figure out the period this time? It's not going to work because it's not pi over a number. So let's go ahead and figure out our period. T is 2 pi over omega. And omega is a half. So rather than doing divided by a half, I'm going to do multiplied by its reciprocal. So my period is actually going to be 4 pi. Oh no. It's all right. It's all right. Take a deep breath. We're going to be fine. Got this. Our amplitude's a nice whole number. That's great. Tell me about our shifts. Are we going left or right? Left by pi and up or down? Up by 4. Okay. We got this. We got this. So we're going to start at the origin, set your pencil down at the origin and move it to the left by pi. And that should be relatively easy to do because you've got a marking for negative pi right there on your x-axis. And then from there, move it up by 4, and that'll get us our new anchor point. From that point, go ahead and go up and down by 4 because that's our amplitude. Oops, you know what I should do first? Let's draw that center line in there. And then go up and down by 4 and go ahead and draw that max and min lines in there. I think that just makes things a lot easier. So far, this hasn't been any more difficult than what we've done before, right? It's the next part that people get a little worked up over. And it's not that big a deal. I need to make my period 4 pi. So I need to start here and I need to count over 4 pi. So think about it. If I start at -1 pi and I'm moving over to the right by 4 pi, where am I going to end up? -1 plus 4 is 3, right? Throw some pi's after each of those. We're going to end up here at 3 pi. So this is going to be the end of that period here. Oh, it's a nice wide one. I like these. Chop it up. I'm curious if those bells end up on the video. What do you think? Or is it just pause? Because the microphone doesn't work when the bells are going. Maybe it still picks up and ends up, I don't know. All right, and we're doing a sine here. So we'll go boop, 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 boop. And just copy those. What do we have? 4 divisions in between each. 2, 4. Got a max there, so there would be a min here. I do want to do our final step this time. So once you get this drawn, could you go ahead and get your calculators out? And let's make sure that we're confident with checking these, because we're going to need to set our window a little bit differently than we have before. Could you guys all get your calculators out so we can check these together? No, I want you practicing with the graphing calculator. Oh, no luck on that yet, huh? You can check one out in the library. Just in the meantime, did you check back with the office today? Okay, I'm just checking to make sure I'm in radian mode. And then I'm going to go to my window. And this is all kinds of messed up here. So my x, notice that my x starts at -3 pi. So I'm going to type in -3 pi. Now, don't be alarmed when you move your cursor off of that, it's going to turn it into a decimal, -9 point something. Okay, that's all right. Just let it do its thing. It's set at -3 pi, so it's going to turn it into a decimal. My x max is at 3 pi also, +3 pi this time. And again, when I move my cursor off of this, it's going to turn it into a decimal. No biggie, we got this. Now we're going to need to set the x scale. The x scale is how often you have a tick mark in the x direction. So the best thing to do is just look at where your first tick mark is. Notice that your first tick mark is at pi/2. So for your x scale, set it at pi/2. And of course, it's going to turn that into a decimal. The y is much more straightforward. It goes from -8 to +8, and my tick marks are going up by 1s. Oops, by 1s. And now that I have my thing set up, I have not typed my equation in, so we'll go ahead and do that. 4 sine 1/2 plus pi. Don't forget double parentheses after your pi. +4. Graph it. And that's all fine and good. I'm going to actually go back to my y equals, and I'm going to graph my center line in here, this horizontal line at 4. I'll put that in y2. I like to do that. It helps me to check and make sure. So I'm doing it because of this 4 at the end, that +4 at the end. That'll put a horizontal line across there, and that just makes it a little bit easier for me to see that that is totally matching up with what we've got on our page. All right. Let's go ahead and do the next one. Can you guys do a little work for me and figure out what the correct format of this equation would look like? Not correct, correct's not bad. That's plenty correct, but I want to get it into a friendlier form. So I need to factor a 2 out of 3 pi. 3 pi divided by 2 is 3 pi over 2. All right, let's draw that center line in first this time. This graph's going to get shifted down 5, right? So the x-axis was not going to be at the x-axis anymore. It's going to be shifted down 5. So I'm going to draw that center line in right away at -5. And then a couple more horizontal lines for my amplitude. My amplitude is 2, so I'm going to go up 2 and down 2. We talked about how the amplitude's always positive, right? That was a common mistake on last year's test. So we've taken care of our horizontal or vertical shift at this point. We don't even need to worry about this -5 anymore. We can just take care of our horizontal shift, and this is going to be to the left, agreed? To the left by 3 pi over 2. Oh, I haven't found my period yet. Maybe I should do that before I go any further. Period is 2 pi over omega. Omega is 2. So it looks like my period is just pi. Ugh, this is going to be one of those annoying ones. That's really narrow. So I need to shift to the left by 3 pi over 2. And luckily, look, it's marked right there, -3 pi over 2. That gives me my left boundary. And how wide is my period? My period is pi. Notice that when you look at the x-axis over here, from 0 to pi is 2 of these ticks. So just start here and go 2 ticks over. I mean, I would also be super happy if you could take -3 over 2 and add 1 and get -1/2. But do what you got to do to be able to get that on there. So this is one of those super narrow periods. We're going to have lots and lots of points. Tedious. We're doing a cosine, so negative cosine. Fun, fun, fun. You guys are drawing the points on first, right? Is anybody going to be the person that just draws the curve straight on there? I actually have 2 people in my 3rd period class who have decided they're going to be that person this year. But nobody in here? Good. Okay. Just so you know, when I grade these, what I do is you remember those old school overhead projectors? They had the clear sheets you put on them. They actually shone up a light underneath them. Have you guys ever seen those? That might be before your time. So I get this clear piece of plastic and I trace my points onto it. Then I'll just hold that over your graph, and if your points match up with my points, and I don't trace the line at all on that clear piece of plastic, just the points. And as long as I see points at my points, then you're good to go. So when you draw your little curve, as long as it's rounded, I do take off points if your curve looks like Charlie Brown's sweater. Okay, it should be kind of rounded. I didn't do such a great job right here. It should be kind of curved. But if you miss a couple of your points when you're drawing that curve, that's okay. As long as your point's there, that's what I'm going to grade. Okay. Okay. 2 more. These are the quick ones. You guys are doing awesome. Thank you. Hey, let's do that thing to make this a little easier on ourselves. Let's draw our max and min line in here, and then figure out where our center line is. Practice your averaging skills. What's the average of -2 and +8? -2 plus +8 is 6, divided by 2 is 3. Our center line should be at 3. The reason I like doing this is a lot of times that center line is going to help you spot those sine and negative signs. When I'm looking at this, I see a nice Wow, I see a nice positive cosine. And I see a nice negative sign. Which one do you guys want to go with? The negative sign? Okay, let's go with the negative sign. I see a negative sign that starts here and ends here. Bless you. All right, we need a period from this. It goes from negative 3 pi over 2 to positive 5 pi over 2. So from negative 3 pi over 2 to positive 5 pi over 2, that's 8 pi over 2, isn't it? Negative 3 and 5, which is 4 pi. All right, so the period's 4 pi. So then omega is going to be that, or sorry, 2 pi over that, which is just a half. We got a vertical shift of 3. And we got a horizontal shift of negative 3 pi over 2. And our amplitude is 1, 2, 3, 4, 5. And that should give us all the pieces we need to get our equation. Yeah, you're right. I did a negative sign and I wrote a negative cosine, didn't I? Thank you. That's my second mistake of the period and like 85th of the day. So I'm glad you guys are on it. Thanks. Thank you. And I'm glad you're willing to speak up and tell me so I don't have wrong stuff on our notes. Since we're here, I might as well check this. Yeah, let's not. Let's just finish this up. Hey, I do want to point this out. I meant to say this when we did this one here. If I were going to check this, do you think I'd be better off typing in the original equation or the new equation? I will go with the original. If I were going to check this on a homework assignment, I go with the original because there's a potential I could have made a mistake when I wrote this new equation, right? So I think it'd be smart to check this against the new equation. I'm not going to because I'm very confident in that. I feel like you guys would have caught me if I made any mistakes. Okay, let's do this last one. So these ones are the most fun in my opinion. We're gonna end up doing some word problems with sines and cosines. And we're just basically going to be kind of sketching these graphs and writing some really weird graphs that go from, have these weird axes and stuff on them. But we got this. This is no biggie. Start by go ahead and draw that line through your maxes and mins. I find that really helpful. Kind of pinpoints what values our maxes and mins are at. 406. This must be going up by 200. So it bottoms out at 200. Max is out at 2,600. And this is where that average thing comes in really handy. How far is it from 200 to 2,600? Well, no, why don't we take the average of them, add them together and divide by 2. So 200 plus 2,600 is 2,800, divided by 2 is 1,400. So we're looking for 1,400, which would be here for our center line. Oh, good. I was a little concerned because when I first looked at this graph, I was looking at cosines and negative cosines, and I didn't have any nice, but we don't have nice cosines. We do have a nice positive sign that I can see once I draw that center line. I see a sign starting right here and ending right here. Of course, there's another one right after that. I'm going to go for that first one there. So it's starting at 0.1. Our period is how much? From 0.1 to 0.4 would be 0.3. All right, so 0.3 for our period, which means omega is 2 pi over 0.3. Now that is not a valid way to write omega. We do not put decimals inside of fractions. Technically, decimals are fractions. We don't put fractions in fractions for final answers in this class. So are you thinking about multiplying this by a fancy version of 1? What's your fancy version of 1 you're thinking about? How? Keep, change, flip. We could do that. What about multiplying it by a fancy version of 1? Let's multiply it by 10 over 10. That would work, wouldn't it? 10 over 3 is not 1. 10 over 10, though. If I multiply it by something other than 1, I change it. But this is not going to change it. That gives me 20 pi over 0.3 times 10 is just 3. 20 pi over 3 is going to work. You were going to do 2 pi divided by 3/10, and you would have gotten the same thing that way. That would work too. All right, so we're going to use 20 over 3 for our omega. We've got to shift to the right by 0.1. We've got to shift up by 200. I think we've got all the pieces we need. Oh, our amplitude. From 1400 to 2600 is 1200. That should get us everything we need to write our equation. And we said sine. All right, we went through a lot of those examples pretty quickly. You guys feeling all right about this stuff? Can you show me on your old thumb meters how you're feeling at this point? Are we plus 200? Hang on a second. Let me see your thumb meters first, and then we'll go back. Oh, plus 200? That is an awesome mistake. That is a fantastic question and an awesome mistake, because I see that a lot. You had a 200 instead of the 1400 here. Can you guys troubleshoot that mistake for me, because I see that a ton. Do you see where the 200 is coming from? And do you see why it's going to be really easy to make that mistake? Because when I shift from the x-axis up, and I'm shifting to the bottom of the thing here, right? And I would have another common mistake, but instead of 200 would be to put 2600 there instead. Remember, we're always going to the center line. I'm so glad you said that. That is fantastic. That's my favorite mistake of the day here. It's not right, but you can totally see where somebody could do it, right? And I guarantee someone in here is going to make that mistake, hopefully on a homework assignment and not on a test, right? So thank you for that. That's fantastic. Any other questions? All right, so basically, I need you guys to finish up the packet that you got Friday, the packet that you got today, the packet that we got last Wednesday, and then there were a few problems out of the book. I'm not adding anything out of the book for today. I know that's a lot. Do your best to get that done for me for Friday. I can give you a little grace on it if you need a little bit longer. If you've got stuff going on, just let me know.